The title of the video is Demonstration of Cognitive Management Systems for Enabling Future Internet Architectures and Scenarios. On the slide you see the names of developers and authors of this presentation, as well as their affiliation. In the area of the future Internet, our focus will be primarily on the radio access segment, so there will be cognitive devices, cognitive access points, which can be flexible base stations, femtocells and wireless access points. Flexible base stations may run different radio access technologies, and also there will be a cognitive network management system which is capable of managing the region. The scenario evolves as shown on this part of the slide, so as it can be seen, it involves various phases. In the area of cognitive management systems, our focus is on the dynamic self-organizing network planning and management tool, DSNPM. It has the ability to monitor context, which means the traffic load in the area and the element status. We have the ability to have the profiles of the elements in the sense of which network technologies they can support, the user profiles, which services they're interested in, and the quality of service, the respective quality of service levels, and also the application profiles, what does its quality of service level correspond to. Policies means which technologies are allowed to be passed through which network radio access technology. These tabs here are for the output of the management tool. Registry is our knowledge, and femtocell tab is for monitoring the femtocells in the area. Through this window I have the ability to instantiate new flexible base stations. For instance, right now I will start a flexible base station with 3 boards which can run on UMTS or on LTE. The base station that we have created is here. We see the 3 transceivers configured in UMTS and also a femtocell in this area. In general, we have an area of Athens which is served by a composite wireless network. Now we're going to inject some traffic load in the network. The traffic load will consist of voice, video and data traffic. On purpose, we are injecting high traffic load in order to create a hotspot. Here we see some average statistics of the traffic load. We see that the cell in question turns to red due to the hotspot, and also a message that is generated towards the man. On the side of the management software, we see the message that was issued by the infrastructure, and we can also see in more detail where the hotspot was. I'm pressing optimize. We're using in general breakpoints in the demonstration in order to enable the viewer to understand some things or take notes. The optimization has finished, so the first issue to see is the RAT and spectrum selection that was done. The first configuration has this core with the 3 transceivers in UMTS. The second configuration with 1 transceiver in LTE, of course, scores more. The objective function that we see here takes into account the user satisfaction by the assignment to higher QoS levels. Here, in these tabs, we have also the ability to optimize the OFDM operation of our network. We will skip this in order to save time. The general idea is that we are trying to use the best subcarriers and as few subcarriers as possible in order to handle the load. In the area of the registry, what we have the ability to record is the so-called reference context, which are situations that have been encountered by our network, and also the way they were handled and the quality of the handling. Taking a look at our simulated network again, we see that the hotspot situation has been resolved. We see different colors now in the cell in question. Here we see the new assignment of the traffic to the different transceivers. We see the average situation. We also have the ability to see the statistical situation of what goes on in the network. For instance, in TRX21, which was reconfigured to LTE, we can see the average number of users, which is higher. We also have the ability to see various other aspects. For instance, we can go to the load. We see that the load rises, but also the capacity of the transceiver is higher, and therefore this load is caused by the delivery of higher QoS and more satisfactory QoS towards the users. In the next phase of our scenario, we will test some cooperative capabilities. I will activate a WiMAX board in the flexible base station. This is captured by the management software, so I am pressing optimize in order to enable the management software to exploit the new capabilities. The exploitation is in the form of assigning some of the traffic that exists in the service area to this additional transceiver. The optimization has finished, so we can go again to the route and spectrum selection tab in order to test our solution. Here we can see, for instance, that through the exploitation of the WiMAX, we can achieve an even higher performance level, QoS towards the user and performance of our network. We go back to our simulated network again, and we see the existence of one more transceiver, a transceiver that is configured to WiMAX. Here again we can see the average situation of the load that has been assigned. The percentage of the traffic that had been assigned to LTE is now assigned to WiMAX. We can take a look at the statistical situation again. So we see that initially it did not exist, then it gets a percentage of traffic in terms of users. Here one can also test the compliance with the average situation, but also see the statistics of the load. Apart from this, an issue to note is the existence of a femtocell in all these situations. The femtocell has been exploited in order to serve users at even higher QoS levels. This is an important aspect of opportunism also, in the sense that the femtocell may exist in the area and so it is exploited. It may also be assigned resources in order to better serve users. In the last phase of our demo, we will show some self-healing capabilities and some advanced cognition mechanisms. I will deactivate the WiMAX board. This is immediately captured by our management software, and so the management starts the optimization in order to handle this situation. As we will see here, the management software will realize that this situation has been encountered in the past. Same traffic load and also same network capabilities. So a solution that is applied, that is selected, is the one applied in the past. This is best shown here, where we see that the matching probability, which shows whether the situation has been encountered in the past, has increased, and also that the optimization delay has decreased, in the sense that we knew the solution, so we could directly apply it instead of searching for a new solution from scratch. In summary, this video was on the demonstration of cognitive management systems for the future Internet. It is work based on various projects that have finished or are currently ongoing. The input that we saw was information and knowledge on context profiles and policies, output mainly on radio access technology and spectrum selection or FTM optimization. There is demonstration of features like self-optimization, configuration and healing, and also there is some background reading in the next slide. Future plans involve the full integration of opportunistic network, the optimization and integration of wireline segments in the access and in the core, and of course larger scale experimentation, pilots, and in the long-term trials. This last slide has some further reading and references.